spokes may display ERD information. It may be difficult to obtain information from the manufacturer's website or point of purchase. This method is used when there is no ERD rim information available. We will use gravity. We begin measuring the inner diameter of the rim from the valve hole. Insert the nipple onto the spoke in the direction of the head. Insert the nipple into the hole. Now mark the section where the nipple protrudes with a marker pen. Use vernier calipers. The measurement is 3.5 millimeters. Measuring the inner diameter of the rim becomes very easy. ERD equals 3.5 by 2 plus inner diameter of the rim at 7 millimeters. Effective rim diameter is 553 millimeters.
Select spoke lacing pattern.
The hub axle width is 148 millimeters. Non-drive side to flange distance is 36 millimeters. Drive side to flange distance is 52 millimeters. The diameter of the non-drive side flange is 62.5 millimeters. The diameter of the drive side flange is 58.6 millimeters. High and hubs often have different flange diameters. Please click Accept. Click to calculate. Spoke length calculation is complete. Install the spokes. Through axle adapters are required for the latest hub standards. This wheel utilizes the cross pattern, which is the standard method of inserting spokes into the flange by alternating left and right. Let's start building a 148 millimeters, 32-hole hub wheel. Next, let's check the spoke installation sequence. First, install the spoke from flange side A out to in direction. Insert the spokes one hole at a time, skipping a hole. Mark the valve hole with masking tape. Install the first spoke next to the valve hole. Jump 3 holes and install the next spoke. Crossing and the number of spoke holes are not important. The method of assembly is the same. The first pattern is complete. Start installing the B-side spokes. Use the spoke next to the valve hole as a reference. Install it in the hole next to the initially installed spoke. Second step, flange. B. Fit the spoke inwards from the outside. Okay, perfect. Secure the spoke in the hole next to the initially installed spoke. Jump 3 holes and install the next spoke. Install it in the 4th hole. Jump 3 holes. Jump 3 holes. Jump 3 holes. Jump 3 holes. Install it in the 4th hole. Installation of the opposite side spokes is complete. Don't forget the valve hole. Third step, flange B. Fit the spoke outward from the inside. Install all the spokes in the empty hub holes. Take a look. Turn it over and hold it. Avoid the valve. Check the direction of the valve hole. Here it is. 1, 2. Third, cross overlap here. Cross overlap here. That's correct. Cross overlap on the 3rd spoke. When the bike wheel spokes cross, the last spoke that meets does not simply pass by, but needs to be overlapped and connected to make a sturdy wheel. Three cross pattern. Jump 3 holes and install the next spoke in a cross pattern. Jump 3 holes. Jump 3 holes. Jump 3 holes. Cross at the last 3rd spoke. Assembled according to the pattern. Now, install the remaining spokes. Finally, the 5th step is to install the spoke in flange A outward from the inside. Install all the spokes in the empty holes. Install all the spokes in the remaining holes. All the remaining spokes have been installed. Lower the installed spokes. Position the spoke in the empty hole. Install it in the empty hole in a cross pattern. Recross and overlap.
Last passing spoke cross. Pass over the 1st spoke. Pass over the 2nd spoke.
Don't forget the overlap on the last spoke.
Cross down the 3rd spoke. Connect the spokes to the nipples.
The pattern is complete. Prepare the through axle hub adapter. Wheel alignment. Prepare the through axle hub adapter. It's a 12 mm axle adapter. If you put it on the hub, you can fix it on the wheel truing stand. Using a spoke wrench, you should be able to determine the start and end of wheel rotation while tightening the nipples. Attach a sticker-like tag to the spoke next to the rim valve hole. To tighten the spoke nipple, turn it clockwise. Tighten all the nipples while leaving a 1 mm spoke thread. Tighten the nipples evenly. Start aligning the left and right centers. Firstly, we will explain the principle behind adjusting the rim left and right. By tightening the right drive side spoke nipple, the rim will move to the right. Conversely, tightening the left non-drive side spoke nipple will move the rim to the left. It is important to note that over-tightening the left spoke nipple can cause the rim to move too far. Releasing the nipple will cause the rim to move in the opposite direction. In summary, the principle is that the tension power balance of the left and right spokes moves the rim and aligns it to the center. For left-right alignment, tighten the nipples about 90 degrees while turning. Refer to the tape attached to the valve. Aim for about 80% of the target tension. Using a dishing tool during the work can save time. Work on left-right center alignment up to about 1 mm. Now, start the vertical alignment. Secondly, let's take a look at how to align the rim up and down. By tightening the peripheral nipples together, the rim will move towards the hub. To move the rim in small increments, tighten or loosen the nipples at least 360 degrees. Loosening the surrounding nipples together will cause the rim to move away from the hub. Vertical alignment of the rim only works when the left and right spoke tensions are adjusted together. There is currently a gap in the rim height. Start from the point of contact. Vertical alignment takes a lot of time. If tightening doesn't make adjustments, find the position where the rim is pushed inward. Then, you need to loosen the nipple at the position where the rim is pushed inward. This operation reaches only about 90% of the target tension. When assembling wheels, the center can become slightly misaligned due to errors in the wheel truing stand. To correct this, a tool called a wheel alignment gauge, or centering gauge, is used. First, let's set up the dishing tool on the non-drive side. Attach the gauge securely without any gaps. Now, fix the gauge in place. Move the dishing tool to the opposite position. The measurement shows a gap of about 4 mm. To calculate the rim displacement distance, 4 mm division by 2 equals 2 mm rim displacement distance. Now, we only need to move the rim by 2 millimeters. Adjust the position of the rim by tightening the left nipple once and loosening the opposite nipple once. This will allow the rim to move without changing the tension of the spokes. Before starting the job, label the spokes and check the starting and ending positions to ensure accuracy. Start the inspection again from the beginning. There should be no gap on the drive side, and if the measurement distances on both sides are equal, the rim is perfectly centered. The rim is currently perfectly centered. The spacing is correct. Check by hand if the spoke tension is generally consistent. The purpose is to find loose spokes. Compare with nearby bicycles if available. Using a tension meter is also recommended. It's good to measure around 20 to 25 for 14-gauge spokes. Align the up, down, and left-right deviations to be within 0.5 millimeters. The wheel alignment job is done excellently. Once again, perform wheel alignment while aiming to reach 100% of the target tension. Finally, conduct one more check for centering as a finishing touch. The spacing is the same. Centering is perfect. High-end rims have minimal vertical deviation. They are close to a perfect circle. There is no wobbling.
네, 됐습니다.
Nice. Good. One wheel is completed. A 39 millimeters wide rim requires a wider rim tape. It is finished. Subscriptions, likes, and comments are greatly appreciated as they greatly support video production. Thank you for watching.